All right, last but not least, we have our particle motion question. Suppose the graph to the right shows the velocity of a particle moving along the x-axis. So this is our velocity graph. We see velocity on the y-axis. We see time on the horizontal axis there. All right, so which way does the particle move first? Well, immediately we see that the velocity function is below the horizontal axis, which means that velocity is negative. All right, and if the velocity is negative, then that means that we're moving backwards, or because we're on the x-axis, we can say it's moving to the left. All right, it's heading in that direction. All right. When does the particle stop? Okay, the particle stops whenever the velocity is equal to 0. So it stops right there, and also right there. So it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it happens at t equals 3, 6, and 10. When does the particle change direction? In order for the particle to change direction, we need to see a sign change. So v changes sign. In other words, v has to cross the horizontal axis. So there is no change in direction here because v is negative before and after t equals 3. But we do see a change in direction here because v was negative and now it's positive. There's no change in direction here because we don't know what's happening after 10. So the only time that the particle changes direction is at t equals 6. Okay, now we get to the challenging one. When is the particle speeding up? So that means that we are looking for both velocity and acceleration to have the same sign. All right, and specifically that means that we want to be above the curve, or I'm sorry, above the horizontal axis. That means velocity is positive. And also increasing. We want to see positive slope. Okay, or we need the curve to be below the x-axis, or the horizontal axis, and going down or decreasing so that it has a negative slope. All right, so here's below the x-axis with negative, here's below the x-axis with negative slope, and then here's above the x-axis with positive slope. So we're looking at 0 to 1, 3 to 4, and then 6 all the way to 9. When is the particle slowing down? All right, if the particle is slowing down, now we need velocity and acceleration to have, I wrote just sign up here. That should be the same sign. My bad. Put that right there. All right, have opposite signs. Okay, so that means we want to be above the horizontal axis but decreasing, or below the horizontal axis and increasing. Right. So I'm going to change colors here real quickly. So below the horizontal axis but increasing would be right there, and also right there. And then above the horizontal axis but decreasing would be that stretch. So we are looking at 1 to 3, and then also from 5 to 6, and lastly from 9 to 10. When is the particle moving at a constant speed? Well, it's moving at a constant speed whenever we see no change in the acceleration. In other words, the slope of our velocity graph is 0. And that's happening right there. So that's going to happen from 4 to 5. All right, because we're looking at a the velocity is flat, basically. That's the idea there. And then last but not least, on the blank graph below, sketch the graph of the particle's speed. Okay, so speed, that is the absolute value of velocity. So we got to take the velocity graph above, and I can't fit them both on the screen. We're going to take that velocity graph, and we want to make sure that it is always positive. So basically we need a mirror image of what we see above if there's any time when the graph is below the horizontal axis, and that's what I'm doing right here. All right, so all these lines were below the x-axis. They were down here. Let me put them in black. All right, this is what the original function looks like up at the top of the page so far. Okay, and I've reflected it over the horizontal axis to make it positive because that's what we're doing here. We want positive. We want non-negative rather. Okay, and then the rest of the curve is actually already above the horizontal axis, so that will not change. And there is the graph of speed, and notice there in red that speed we know is non-negative, and that graph is always at or above the horizontal axis.